Hello everyone, welcome back again in our channel. In this video, we're going to discuss about the ICMP protocol. Okay, now ICMP stands for Internet Control Message Protocol, right? And this protocol is used for various purposes in our day-to-day networking and troubleshooting life, right? And mostly this is used for diagnostic and the error reporting. Okay. Now, what I mean by diagnostic and error reporting, uh, and diagnostic, I mean network diagnostic, for example, checking the reachability, the round trip time, the TTL value, right? And by the error reporting, I mean, whether the IP is reachable or not, or the port is reachable or not, or it also tells you, if there is a IP fragmentation happening or not, right? So that's how this protocol helps you to report these things. Now, the ICMP, to use this protocol, basically, right? You use a command, ping, and that command you can run it from any CLI, terminal. For example, in Windows, you can use a CMD command line tool, and in the Mac, you can use terminal, or in router and firewall, you can of course use the same CLI, CLI for these devices, and you can run ping, and then you can give it a host, whichever the destination you want to ping, and the underlying protocol it uses, that ping command is basically the ICMP. Okay, so this ICMP, right, is typically it's kind of a layer 3 network layer protocol based on the OSI module, right? And why this is layer 3 protocol? Because it deals, with the network related functions. There is no, UDP or transport layer TCP protocol involved, and that's why this is a network layer protocol. Okay. Now, let us do one thing. Let me just quickly, start the Wireshark capture, and I'll ping it a host, and then I'll show you how this ICMP looks like. Okay, so let me ping 8.8.8.a. Okay, and now you can see as soon as I ping 8.8.8. I got a response from that, right? So you see reply from 8.8.8. The data byte was sent is 32 bytes, right? The time it took is 74 milliseconds, and the TTL value is 128. Okay, so now let's just go a little deep, and let's just look at the header field of this ICMP packet. Okay, so I have this, this ping, or captured in Wireshark. So if I select the very first value, this is my source IP address. The destination I ping 8.8.8, and you can see at bottom I have this ICMP uh, header. Okay. Now in this ICMP header, the first value you see, uh, that's a type field. Okay. This is a 1 byte field in the ICMP header, and this type field basically determines the purpose of this this ICMP packet. So in this case, if you can see that type field says number 8, the value 8, that means this is a echo request, right? If this field is, for example, type 0, that means it's an echo response. And let me just select the second packet, and you can see, right? The type field value is 0. Okay, so type field tells you the purpose of the packet. It's an echo request and reply in our case. And okay, and let me give you another example. For example, if type field value is 3, that means it indicates that destination unreach. This is a destination unreachable message. Okay. Now, what is this code field? Again, this is a 1 byte field, and the code field is basically tells you more about the type field. So let's say if you know if type field is 8, and based on the type field, right, the code field value could be anything. So in case of ICMP request and response, the code field value is 0 only, right? But if you use a different type field, or let's say that if the type field value is 3, you may have a code field value 0 or 1 or 2 or 3 or 4 or 5, right? And these are the predefined values. Okay. Now, what when using that, when the type field is 3, what the code field 0 means and what the code field 1 means. So if the code field is 0 when type field is 3, that means network is unreachable, right? Because type field 3 says destination unreachable, but what is exactly unreachable? The code field tells you more detail about it, that network is unreachable. And then if it's 1, then maybe then it says that host is unreachable, right? And if it's 3, that it tells you that the port is unreachable. Okay, so that's what the type field is. Okay, now the checksum field, this is a 2-byte field. Okay, and this checksum is used for the error detection and ensure that integrity of this whole ICMP packet. Okay, make sure that this is not tampered in between or modified or something. For that purpose, there is a checksum value in this ICMP packet. Now question comes in that how this checksum value calculated. So this checksum value calculated, including the type of field, the code field, right, and of course the data portion of this ICMP packet. Now the next field what we have is called the identifier field. Okay. Now the identifier field, it's again a 2-byte field, and this is there to to help to identify, match the request and response in the echo request and reply. So if you see, this is matching the request and response. Okay, now how this identifier field works, what happens when you send an echo request, right, or when a source send an echo request, it sets the identifier field value. So if you can see in this case, the source IP address 192.168.142.199 has set a value of identifier bit as a 2. Okay, now the corresponding response value, right? The response value when the destination responded, what it does, it add the same value. It copies that the identifier value from the source, and it copies that value and put it in in the identifier bit or identifier value in its response, right? That's how this identifier bit value works. Okay. Now, you may be confused, right? That okay, I understand the identifier, value and bet, but why it's twice there? And what is this B and LE? Okay, so to understand the B and LE, you need to understand the Indianness term. Okay, so let me just write it down because this is to give you more context. So before understanding that B and NE field, right, you need to understand the and Diana field, right? Okay. Yeah, this is the Indianness field you need to understand. Now, what is this Indianness field or term? So this term basically define, the order in which the sequence of bytes are stored in the computer memory. Okay. So what it means that where exactly, right, these sequence of bits are stored. And why this is important? Because in a different computer architecture, right? They stored the value, like the identifier value, in different order. Okay, and that's why the value B in L is there. So BE tells you that the most significant bit stored is stored first, right? The most significant bytes are stored first, and LE tells you the least significant bytes are stored first, right? So this is basically how the bytes start stored. Okay, that's what this B and LE stands for. Now the next field what we have is called the sequence number. Now the sequence number again, to identify, it's again a unique number to identify each request and response. And this is again similar way the way the identifier field value works. The sender sends sets a sequence number, a random sequence number it generates, and the responder copy the same value in its response in a sequence number. And you can see in a very first okay, let me just note. So you can see in the very first two packet, the sequence number value is 45 45598, and that's from the source 192.168.140.129. But the second packet, you can see that source is from 8.8.8, but the sequence number value is same. This is because this the destination, when it respond back, and you can see this is an echo reply, right? What it does, it copies that value, okay, to its own sequence number. And that's how you can you can match the request and response. Now how you do it, if you simply put a filter, right, for a sequence number, and you just follow this. Let's say you want to follow let's okay 9, right? So if you follow that sequence number, the sequence number would be same, right, in the request and response packet. And that's how you can identify that you send a packet, ICMP packet, whether you have received the response of this packet or not. Okay, so in this case, you can see we send a packet and we got a response, and the sequence number value is same. Okay. Next in this, in this ICMP header is the data field, and which is a 32 bytes of data. Okay, so yeah, this is it's only a 8-byte field, 8-byte this ICMP message, and that's all regarding this ICMP protocol. We only have these many fields, and we have discussed all these fields in details. Uh, in our next training, I'll go in more details and I'll tell you, more about the, different type and codes. Okay. Thank you very much for watching. See you in our next training. Bye-bye.